All right, y'all, let's talk redox reactions. So when I say redox, I mean oxidation and reduction. It's a general idea. So oxidation, reduction, redox, same idea. Okay. So when we talk about redox reactions, in order for this to happen, we have to have electrons being transferred. Okay, something is being oxidized, something is being reduced, hence the reason we call them redox. For stuff that is being oxidized, it's losing an electron, and for stuff that is being reduced, it's gaining that electron. Okay, so oxidation, loss of electrons, reduction, gain of electrons. Again, for something to be a redox reaction, something has to be gaining electrons and something has to be losing those electrons. Okay, and so here's a kind of way to look at that. Oxidation is loss. So I'll show you a different kind of way to think about it. Like a acronym, I think. Oxidation is loss of electrons. Okay, so if something is being oxidized, it's losing electrons. The thing that is losing the electrons is called the reducing agent. Okay, so something is being oxidized. It's whatever is causing that thing to be oxidized, right, is going to be our reducing agent. Okay, we'll talk about this in a little bit, but reducing agent, oxidizing agents can only be reactants. Okay, and so in reduction, we're gaining electrons. When we gain electrons, we become reduced, and the oxidizing agent is what is causing that reduction. Okay, so if you look here, here's my oxidizing agent. It's gaining electrons to become reduced. My reducing agent is losing electrons and becomes oxidized. Okay. And so, like I said earlier, kind of a way to think about it, a way to remember this, oil rig, oxidation is loss, rig, RIG, reduction is gain. Okay, so oxidation is loss of electrons, reduction is gain of electrons. Usually whatever is being causing the oxidation is the reducing agent, okay? And whatever is being causing the reduction is the oxidizing agent. Again, think about it. If I'm gaining electrons, I'm causing something else to be oxidized, okay? If I'm losing electrons, I'm causing something else to be reduced, okay? So think about it in that way. Okay, so we can assign oxidation states or norms. So, okay, we've talked about oxidation reduction. Well, how do I know what is being oxidized? How do I know what is being reduced? It's by assigning what we call oxidation states or numbers. I will use these interchangeably. So if I ask you to find the oxidation state or the oxidation number, I mean the same thing, okay? There's a slight difference between that, but for the purpose of this class, we'll just go with it, okay? The oxidation, so for an ionic compound, the oxidation state is going to be the charge. Okay, so we'll work through a few problems, but if I have an ionic compound, my oxidation state or my oxidation number is the charge that's on that compound. For covalent compounds, remember with covalent compounds, there's no such thing as ions, right? We don't have ions in covalent compounds. So when we talk about our oxidation state or oxidation numbers, they're essentially imaginary numbers, okay? We can have positive, negative, or zero and fractional values of oxidation states. So we can have an oxidation state of +7.5. So +7/2. That's very good. Okay. And we determine oxidation states per atom. So if I had NaCl, I would determine the oxidation state for Na and Cl. And not just, hey, as a whole, the oxidation state of this compound is blah. Okay, so we determine by atom. And so those are the rules, kind of, or general guidelines for when we assign oxidation states. There are a few rules that apply, and these are in order of priority. So you kind of check these off as you think through your assigning oxidation states. So first off, it's a free element in its natural state. The oxidation state is 0. So Na, sodium is a solid. Oxidation state of sodium as is 0. Chlorine is diatomic, so it does have to have a 2. It's a gas. The oxidation state here is 0. Okay, so that's the first rule. The second rule, if I have a monatomic ion, the oxidation state is going to equal its charge. So in NaCl, Na carries a +1 charge, Cl carries a -1 charge. Those are the oxidation states for both of those things. In a neutral compound, the sum of oxidation states has to equal 0. So in NaCl, that's a neutral compound, there's no charge on it. The sum of oxidation states for each thing, so for Na and Cl, have to equal 0, and they do. +1, -1, 0. Okay? in a polyatomic ion, when I sum the charges, it has to equal whatever the charge is on that polyatomic ion. So in nitrate, the charge on nitrate is -1. The charge on, or the state, or oxidation state for nitrogen is +5. For oxygen, it's -2. We'll talk about how we got there later. But when I sum those up, it has to equal the overall charge on nitrate, which is -1. Okay, all right. General rules for kind of, so we talked about monatomic ions, they carry whatever charge they have from a periodic table. For oxygen, it usually is going to be -2. Okay, so again, you do need to know this. For hydrogen, it's usually going to be +1. There are exceptions for both hydrogen and oxygen, but you usually carry a state of -2 for oxygen and +1 for hydrogen. And then fluorine, which is on here. Okay, so here are kind of, it's a summary of the rules I talked about in terms of the individual elements. So group 1, always +1. It's on the periodic table. It's gonna form a +1 charge. Group 2, always +2, no exceptions. Fluorine, always -1, no exceptions. For these, we don't have exceptions, right? It's what the charges are gonna be, the oxidation states for these elements. Chlorine, usually -1, except if it combines with something that's more electronegative than it is. We'll talk about electronegativity later. But when it combines with oxygen and fluorine, those two take priority. So fluorine would be -1, oxygen would be -2. Excuse me. Oxygen is usually -2, except when it combines in peroxide. So peroxide is like an H2O2. Like two things of that thing. And fluorine. So fluorine, again, there are no exceptions to that. It's always a -1. So if it combines with oxygen, oxygen has to take the positive. And then hydrogens are usually +1, except in metal hydrides. So metal combining with a hydrogen, hydrogen is going to take a -1 in that case. Okay, again, sum of oxidation numbers or states in a neutral compound is 0. And in a polyatomic ion, it has to equal that charge on the ion. Okay, all right, so let's work through this. This hopefully is a review for you, because we've talked about protons, neutrons, electrons, things like that. But then we also can look at how we figure out the atomic the oxidation states and how we determine what's being oxidized and what's being reduced. So real quick, take a look at this. Based on our rules, this should carry a 0 and a 0 oxidation state, right? Iron is a solid, oxygen, gas is diatomic, it's a 0. Okay, so number of protons in iron is 26. This comes from periodic table. And down here too. For oxygen, it's 8. Also periodic table are down there. Remember, number of protons, atomic number, the same thing. In this case, number of electrons is the same. This carries a plus charge, and so the number of electrons here is 23. Number of electrons here is the same. The number of electrons here is 10. Okay, the change here is a 0. Here is a +3, 0. Here's a -2. So iron is going from 0 to +3. Is it gaining or losing electrons? It's losing electrons and becoming more positive. And remember, loss of electrons is oxidation. And on the flip side, oxygen is going from 0 to -2. It's gaining electrons. Electron gain is reduction. So in terms of the zeros, hey, we got that. Okay. Here, iron carries a +3 charge. Oxygen carries a -2. It's an ionic compound, so the charges on those things will be what we're dealing with. So you first assign charges or oxidation states, and then you look at them, hey, what's gaining electrons, what's losing electrons? And that's going to tell you if you're being oxidized or reduced. Here's another one. You can pause this and work through it by yourself if you would like. Oxygen carries a 0 charge, or oxidation state. In this case, hydrogen also carries a 0 because they're both in their elemental state, natural state. Oxygen carries -1, -2. Hydrogen carries +1. Oxygen is going from 0 to -2. It's gaining electrons, which makes it being reduced. Hydrogen is going from 0 to +1. It's losing electrons to become more positive. It's being oxidized. Okay. Oh, and so in this case, because oxygen is being reduced, it's the oxidizing agent. It's causing something else to be oxidized. Okay, so oxygen is being reduced, making it the oxidizing agent. Hydrogen is being oxidized, making it the reducing agent. So because hydrogen is being oxidized, it's causing something else to be reduced. Okay, and so in terms of the number of electrons there we go. Okay, all right. So real quick, pause and kind of work through this on your own. I'll talk through this like now, but go ahead and work through it on your own. This should have a 0 charge state because it's in its elements. This would carry a +1. This would carry a -1. It's an ionic compound. This carries a +1. This whole thing would carry a -1 charge because it's the chlorate ion. But individually, this would carry a -2 charge. So oxygen carries a -2. And so let's talk this out. So ClO, actually, we don't have to work through this as an ionic compound. We can, and I'll talk you through later, but this is going to carry a -2 charge, and I have 3 things of it. So potassium is +1, plus I don't know what chlorine is. That's what I want to figure out, plus 3 things of oxygen, and this all has to equal 0. So if you did it the other way that I was going to do, so put the ClO3 minus and set, so ClO3, Cl we don't know, O is -2, 3 of that has to equal -1, you're going to come out with the same answer. Okay, so it doesn't matter. So 1 plus x minus 6 equals 0. X equals 6 minus 1, which is 5. Okay, so the charge on here is 5. Okay, for me to figure out what's going on, I got to assign the states, which is exactly what I've done. And so K is going from +1 to +1, and that's nothing. We can take that away. Chlorine is going from +5 to -1. It's gaining electrons, which means it's being reduced. It's becoming less positive. It's becoming more negative. On the flip side, oxygen is going from -2 to 0. It's becoming more positive. It's losing electrons, right? Going from -2 to 0. It's losing 2 electrons. It's being oxidized. And so in this case, the atom that's being reduced is chlorine. The atom that's being oxidized is oxygen. In this case, the reducing and the oxidizing agent, they're both on the, so anytime you think reducing, oxidizing agent, it's always going to be on the reactant side. There's only one reactant. KClO3 is the reducing and the oxidizing agent. Okay. It both causes something to be reduced and something to be oxidized. Here's another one. Again, pause, go through it by yourself, make sure that you're able to assign things that need to be assigned, and then listen to me walk through it. Okay, all right. Magnesium carries a 0, nickel carries a 0. They're both solids in the natural state, and so they have a 0. Excuse me. So in this case, because my polyatomic ions are staying together, I'm actually going to keep them together. There's no need to break them up. If they stay together, they're going to have the same charge. So I'm going to ignore this because it appears on both sides. It's going to have the same thing on both sides. But nickel is going to carry a +2 because SO4 carries a -2 on both sides, and magnesium is going to carry a +2. Okay, you're welcome to work through each and assign charges on there, but you're going to find that the states are the same, which is why I'm not doing that. Magnesium is going from 0 to +2, which makes it be oxidized, and nickel is going from +2 to 0. It's gaining electrons. It's being reduced. And so the atom that's being reduced here is nickel. Atom that's being oxidized is magnesium. My reducing agent is the whole thing. So not just the atom, it's the whole thing. And so my reducing agent in this case is magnesium because it happens to be by itself. But my oxidizing agent is nickel 2 sulfate. Okay, so your agent is whatever that reactant is. If it's by itself, great. If it isn't, it's the whole thing. Okay. Okay, so NiSO4 is the oxidizing agent, and magnesium is the reducing agent as well. Yep. You can, or you can work through it if you like. Totally up to you. All right. Again, pause this. Go ahead and work through this and make sure that you're able to get where you need to get to. I will have the answers on the next slide, but pause this, make sure you can get through it. And yeah. Okay. All right. So here are the worked through answers. Again, ionic compounds will have whatever the state is as the whatever the charge is as their state. For HNO2, the way I did that was right here. So H is a +1, O is a -2. Again, go back to our rules and then solve for X, which in this case happens to be nitrogen. ClO4, same idea. I know what oxygen is, it's -2. I have 4 of those, it has to equal -1. And so then I solve for my X, okay? CH4, I know H is a +1. Solve for X, it has to also equal 0. CO2, I know what O is, I can solve for C, okay? Hopefully that makes sense. Again, work through your homework. Go through all of those and just make sure you're able to work through these different, how to figure out the different oxidation states and numbers. Okay.